Hi, my name is John Ramsey. I'm here at Selig today, and we're going to run through some of the applications and how to use the JRE Test TVK Test Validation Kit. The kit comes in a standard size box with a high power signal source and a handheld spectrum analyzer and of course chargers to run it. It's all battery powered. I also brought along a typical test enclosure so that we can actually do a measurement and you can watch it and see how we do it and how you can use the test validation kit to find any leakage in a RF shielded environment. Inside the validation kit, we have a high power signal source. The high power signal source generates a signal of plus 25 dBm, which is about a quarter of a watt at 2.45 gigahertz. It's a synthesized source, meaning that it's on frequency, there's no adjustments, and it's crystal controlled. The reason for that we'll get into later. The second piece is the handheld spectrum analyzer. It runs on a lithium-ion battery. It will run for a few hours. And then we have a Yagi antenna, which simply attaches. There's no buttons to adjust, no adjustments whatsoever. The unit is already calibrated to work at 2.45 gigahertz. It has a very narrow IF bandwidth, and that's very important to get high sensitivity because we're going to be measuring isolation in the 100 dB range. And so to be able to do this with a small, low-cost handheld spectrum analyzer makes it very, very attractive. Okay, we have the test signal source inside the test enclosure. We're ready to check, and we didn't close the lid yet. You'll notice the lid is sitting firmly on top of the shielding, but yet the test analyzer still indicates signal is leaking out. Now we'll latch up the lid, and you can watch the signal go right down to nothing. Okay, now with the test enclosure fully sealed, we can use the handheld spectrum analyzer to see any points of leakage. Now it's wise to remember that the spectrum analyzer can actually show us 100 dB of dynamic range. Even though it's a small size screen, nevertheless, we can measure up to 100 dB of isolation. So the test enclosure is spec'd at about 80 dB, so we should see little pips in different areas where there is some leakage. Still well within specifications, but nevertheless we'll show you how this can be used to track down any leakage that one might find. The directional antenna, Yagi antenna, is run along all the seams. And this will indicate any leakage that is coming from the door area. In this instance right here, we can see that there's about minus 93. The I/O plate is removable, so there's a bunch of different kinds of plates you can put in with different interfaces, whether it's a 4-terminal strip, SMA connectors, USB, Ethernet, whatever. But in this case, we have a standard I/O plate with a 4-terminal strip, 2 bulkhead SMA connectors, and a filtered USB 2 interface. So let's take the spectrum analyzer and look around this area and see if we have any leakage. Well, we can see it jumping around here, picking up local Wi-Fi, but the actual little spike, which is always in the middle, coming from the test source inside, we can see is well below 100 dB. So this assures us that there's no leakage whatsoever coming from the I/O plate area and very low leakage coming from around the door seals. Okay, we saw that the box was sealed up really well, had very, very low leakage. Now, let's play with messing up the conductive seal on the top. We'll unlatch it and take a simple business card, put that between the door and the seal. Now remember, before we measured about minus 93 dB of isolation. Now let's take a look at it. Holy cow, minus 63. A 20 dB difference in isolation shielding just by having this piece of paper in the seal. Now you may wonder why we have such robust interfaces to get in and out of the test enclosure? Well, we saw that how critical it was to have a good seal all the way around. We lost 20 dB of isolation just by having a piece of paper in here. Well, what some people have tried to do in the past is run wires in and out of the test enclosure, and they think just by closing it up and having the wire run through, they're still shielded. Let's take a look. Here we see leakage, minus 47 dB. We lost almost 40 dB of isolation just by having this piece of wire, small little speaker wire, going through the door. So everything that goes in and out of the test enclosure must be suitably shielded, or else you're going to notice this. So what we saw today is that with the JRE TVK test kit, you have everything you need to check the shielding isolation of your test enclosure. Handheld spectrum analyzer, high power signal source, no controls other than an on-off switch. Very, very easy to use.